Hello, it's November 26, 2013. I'm doing a MathBabbler bit. And it all started when I got tagged in a Facebook posting. And the posting was nothing more than information saying that the number 2520 was the smallest number that had 1 through 10 as its proper divisors. In other words, the numbers 1 through 10 all evenly divide into 2520. Well, I didn't know that, and it made me a little curious as to what were the smallest numbers that had 1 through 3 as proper divisors, and 1 through 7 as proper divisors, and 1 through 12 as proper divisors. So I wrote a program. And the program calculated and printed that information out, and the program printed that the number 360,360 was the smallest number that had the numbers 1 through 15 as proper divisors. Well, I typed this number 360,360 into this collection of programs that I have called the MathBabbler Number Analyst, the MBNA. And one of the things that that program does is it sums up the proper divisors for a number. And with respect to 360,360, if you sum up its proper divisors, it equals 1,212,120. That makes this number an abundant number. When you sum the proper divisors of a number and that sum is greater than the number itself, you have what's called an abundant number. And so 360,360 is a highly abundant number. But when I saw this number, 1212,120, I said to myself, if we incremented this number, in other words, if we just added 1 to it, we would get a palindromic number, 1212,121, or 1,212,121. This number, if we read it this way or read it that way, we get the same number. So I went ahead and I took this number and I typed it into the MathBabbler Number Analyst, and it told me that it was palindromic, which I already knew, but it also reported that the number was prime. Prime numbers, regardless of their magnitude, have only one proper divisor, and that's the number 1. And so I thought it was a little bit interesting that here we have this number here, which, by the way, this number is abundant. When you sum up its proper divisors, you get a number that's like 3.7 million. So this is an abundant number, but add 1 to it, and you get a number that is highly deficient. Its sum of its proper divisors is 1. So I thought that was a little bit interesting. And then just from a number perspective, the program also indicated that 720,720 is the smallest number that has the numbers 1 through 16 as proper divisors. And an observation that we made was that this number, 720,720, is exactly 2 times 360,360. So there must be something behind that. Well, I've been spending a lot of time with these numbers. Hopefully this MathBabbler bit will put these numbers to bed and we'll be able to carry on. End movie.